So because of the right-hand rule, the top wire has a current to the right. It's in that red magnetic field that's directed out of the page, and we get a force down. Now, let's see. So the force on a current carrying wire, the force on a current carrying wire is Philb, F-I-L-B. And what's the angle between the magnetic field and the current carrying wires? The current carrying wires are to the right. The magnetic fields are either into the page or out of the page. What's the angle between that? 90 degrees. So sine of 90 is 1. Okay. So the magnetic force on the bottom wire, I'm going to put B for bottom wire, is due to the magnetic field of the top wire. Do you remember how to find the magnetic field around a wire? Isn't there an equation for that? Anybody? The magnetic field of a wire? So mu naught I top, because it's created by the top wire, divided by 2 pi r, and instead of r I'm going to call it d, because r is the distance from the top wire to the location of the bottom wire, and the bottom wire is a distance d from the top wire. So you can call it r if you want to, but in most texts you'll see it as a d. Now let's look at the top wire. The magnetic force on our top wire, so the magnetic force would be I top L times the magnetic field due to which wire? The bottom wire, which would be mu naught I bottom over 2 pi r, and r would just be the distance between the two. What do you notice about those two equations? They're the same. Oh my gosh, Newton's third law is totally correct. For every force, there's an equal and opposite force between two bodies. Yay! So we could write that the magnetic force between two wires is, we usually put the constant out front, mu naught I1, I2, L over 2 pi d. So for this one, what have we been given? So with the magnetic force, mu naught is 4 pi times 10 to the negative 7. The currents were each, what, 110? Is that correct? The length, was that 270? Divided by 2 pi d, and the distance was 25 centimeters, which is 0.25 meters. We need to make sure we convert that. So what do we get as the force between these two wires? All right, so 2.6 newtons.